Hello everyone. In today's class, we will learn defects of vision. Defects of vision. So let's see one by one. Okay. So first one, that is myopia. What is this myopia? They will ask you 2 marks question. This myopia is also called as short sightedness. Short sightedness. Okay. In this, person can see near objects but can't see far objects. Person can see near objects but can't see far objects. Next. Now, defected eye and correction. Let's draw the diagram for it. So this is what the defected eye, and how we are going to correct it. We will take one defect at one page. So I'm erasing this part. So this is myopic eye. And then how to correct this defect? So we are going to use this concave lens for its correction. So this is a correction. That is which lens we are going to use? Concave lens. Correction is what, or how we are correcting this defect? That is why using concave lens of suitable focal length. So this is a myopia. Myopia is a short-sightedness. The person can see near objects but can't see far objects. The all range converge before retina, so that's why we are unable to see properly, or the person who has myopia, he will unable to see the proper object because image is not getting from on the retina. Yes, and if you want to correct this, we will use this concave lens of suitable focal length. This is what first defect, that is called myopia. Let's move ahead. Next defect, that is hypermetropia. Next defect is what? Hypermetropia. Continuation of that part. That is hypermetropia. This is what? Second one. One more point. Do we have space here? Okay. So if we want to find power, in this case, one formula we will write here. So power P is equal to 1 by focal length, and this 1 by F is equal to 1 by far point minus 1 by minus of distance of object. Okay, this you can keep it in mind, this formula, in case of myopia. Next, so this is hypermetropia. This hypermetropia is also called as long-sightedness. In this, person can see far object but can't see near objects. Person can see far objects but can't see near objects. Person can see far objects but can't see near objects. And if we will see the diagram, that is how image is going away and what is its correction. can see in the diagram how image is getting formed, or these rays are converging not on the retina but out of the retina. For correcting this type of defect, we are using convex lens of suitable focal length, so that this all rays converge on the retina and the person can see image of the object. Hypermetropic eye and correction is convex lens. We are using convex lens of suitable focal length. In this case, if power you want to find, power P is equal to 1 by F, which is equal to 1 by 0.25 minus 1 by near point. This is what formula for finding the power in this hypermetropy. Okay, so next defect of vision, that is presbyopia. Next is what? Presbyopia. So what is this presbyopia? Basically, this occurs in old ages or old age people. So power of accommodation decreases. Power of accommodation what is power of accommodation? Ability to change the focal length, you know, by using or with the help of ciliary muscles. In 10th class, you have learned this all. So this power of accommodation decreases, and because of this, both near and far objects not clearly visible. Both near and far objects not clearly visible. Not clearly visible. And correction of this type of defect is you should use bifocal lens. Bifocal lens means mixture of both concave and convex, like that. Bifocal lens. This is what all about this presbyopia. Right? This is what your presbyopia is. Next, astigmatism. One more defect is there. Let's see that also. Astigmatism. So this astigmatism is why it is occurring. If you will see the eye has cornea, yes, and cornea has unequal curvature in different directions. So because of that, astigmatism is getting occurred, right? So see here, cornea has unequal curvature, has unequal curvature in different directions, in different directions, and because of that, unable to focus on vertical and horizontal lines simultaneously, or because of this defect, unable to focus on vertical and horizontal lines simultaneously. So because of this defect, the person unable to focus horizontal or focus on vertical and horizontal lines. Focus on vertical and horizontal lines simultaneously. Correction for this defect is cylindrical lens. Correction for this type of defect is what? Cylindrical lens. Okay. What is the correction for this type of defect? That is cylindrical lens. Next, one problem, how they are asking you problem on this type of cases. Even you might have solved before, but still I am taking one problem on this. So listen here, problem number 1. A person cannot see distinctly any object. A person cannot see distinctly any object placed beyond 40 centimeter. Placed beyond 40 centimeter from his eye. Find the power of lens. Find the power of lens which will enable him which will enable him to see distant stars clearly. to see distant stars clearly. Is okay. So this is the question. So you might have understood this, what he is saying. If any object or a person is there who cannot see distinctly any object placed beyond 40 centimeter, means until and unless someone is coming near to the 40 centimeter, he cannot see or she cannot see, right? So we have to see now what is given here. So his far point is given. His far point is equal to 40 centimeter, which is equal to 0.4 meter. And distance of object, so as he is going to see stars, so distance of object is what here? Infinity. Right? Distance of object is equal to infinity. Now you know power formula. So power P is equal to 1 by F, which is equal to 1 by what you are having. Have you seen before? Already I have given. You can see here. This is far point minus distance of object, right? Can you see here this one? So let's see now. 1 by this is minus 0.4, or shall I write first formula? Okay, I will write first formula. So this is first is far point. FP means far point minus of 1 by minus object distance. Now here this is 1 by minus 0.4 minus 1 by of minus infinity, this is going to be 0. So 1 by minus 0.4 is your power, that is 1 by F, and therefore power P is equal to minus 10 by 4, and this power P is equal to minus of 2.5 diopter. Is that clear? So what type, which lens you should use? The lens, which type of lens this is? Concave or convex? Concave. Why? Minus you are getting. So here you should use the lens of minus 2.5 diopter, then only you will be able to see the stars. Minus for concave lens, plus for convex lens. You know this. Let's solve one more problem on this. Okay. Next one. So another problem. A far-sighted person cannot focus distinctly on objects closer than 1 meter. On objects closer than 1 meter. What is the power of lens that will permit him? What is the power of lens that will permit him to read from a distance of 40 centimeter? To read from distance of 40 centimeter. Okay, like this question they have asked. So as you know, this is far-sighted person means what? Hypermetropic eye. Hypermetropic eye means definitely convex lens you have to use. So here direct I am writing now, near point is equal to what here? 1 meter. Okay. And U is what now? Next time 40 centimeter. So this will become 0.4 meter. So you know formula P is equal to 1 by F, which is equal to 1 by near point minus 1 by U, and object distance. So this is equal to 1 by near point is what? Minus 1 minus, and 1 by U is what? 1 by again minus 0.4. So this is going to be minus 1 plus 1 by 0.4. So if you will see this, how much you are getting? Its LCM is nothing but 1. So minus 0.4 plus 1. Yeah? So this is equal to minus 0.4 plus 1 divided by 0.4. Therefore, power P is equal to 0.6 by 0.4, which is nothing but 6 by 4. And therefore, power P is equal to 3 by 2. And hence, power is equal to 1.5 diopter. So, which type of lens you should use? Convex lens. Here only you should understand. Once he is far-sighted person, definitely it will come convex lens only, and power will be plus. Okay. So note down this, try to understand, and let's stop here.